Hi there, guys. So today here, I'm going to be going over a horizontally connected system. And this one here in this example is consisting of three blocks. So here we have shown below three blocks. So mass 1, 20 kilograms, mass 2, 15, mass 3, 10 kilograms, with a constant pushing force of 50 newtons being exerted on your mass 1. And we're assuming frictional forces are negligible. Okay. So the first thing I would actually do before I actually do this question is identify all the external and internal forces. Okay. So in this example here, what we have is we have your 50 newtons. So this is our pushing force. So I'll label that as FP. And that's pretty much all our external forces. Okay. So external forces are forces acting on the whole system. Okay. So what we also have in between the blocks is the forces of the blocks on each other. Okay, so in this case here, we have the force of 1 on 2, the force of 2 on 1, the force of 2 on 3, and the force of 3 on 2. Now, if we kind of go back to Newton's third law states that two forces are equal and opposite if they act on the same two objects. And in this case here, we know that it's FA on B equaling to negative FB on A. So that's the kind of equation for Newton's third law. If we have a look at that, we can see that your forces in between the blocks are equal and opposite forces. Okay, so that's something just to keep in mind when we do the analysis for this question here. So here I could also write down my vertical forces. So I could write down my gravitational and also my normal. But in this case here, they're just going to cancel out and they're not associated with the acceleration in the horizontal direction. Therefore, I'm actually not going to look at them and I'm not going to label them. Okay, so these are all the forces acting in your horizontal direction. So now they want me to calculate the acceleration of mass 1. So one thing that we need to understand is that the acceleration, so A of each block, is equal to the acceleration of the whole system. Okay, so a good analogy is the trolley analogy. So if you're pushing 10 trolleys at 2 meters per second, that means that each trolley itself is also traveling at 2 meters per second. Okay, so the same thing here with these three blocks. If these three blocks are traveling at, let's say, 2 meters per second to the right, then that means each block is also traveling at 2 meters per second to the right. Okay, so the reason why I've stated that first is we can actually calculate the acceleration of the whole system. And therefore, we can say that the acceleration of the whole system is just going to be the acceleration of block 1. Okay. The reason why you wouldn't actually find the acceleration of block 1 is if I kind of isolate this body. So I just kind of look at it in terms of just this body and what forces act on mass 1 only. What you're going to find is that you have, first off, the 50 newtons pushing it, and you got the force of 2 on 1. Now, if I kind of write this out, I do F net equaling to 50 minus F2 on 1. And we know from Newton's second law, net force is equal to MA. Can we see how in this case here, I have two unknowns? Now, we can't solve for acceleration if we have two unknowns and only one equation. So that's why this one here is not going to be valid. Okay, so hopefully that makes sense. Okay, so I'll just put a red cross there. Okay, so now let's try analyze the whole system as a whole. So the only forces acting on all three blocks is going to be your 50 newtons. Okay, so therefore I can say that F net equals to your pushing force, which is 50, and that equals to MA. Okay, so I can rearrange acceleration equals to 50 divided by the mass. And in this case here, because I'm analyzing the whole system, I have to include all the masses of the system. Okay, so therefore it's going to be 20 plus 15 plus 10. okay? So it's going to be 45, okay? So in that case here, that's going to give me an acceleration of 1.1 meters per second to the power of -2. And there we have it. That's part A done. So now let's have a look at the next bit. So what is the force exerted by mass 1 on mass 2? So in this case here, they are asking for me to find this force, mass 1 on mass 2. Okay, so this is an internal force. So whenever you're asked to find an internal force, we have to instantly think we have to isolate the body. Okay, so we either have two options in this case. Okay, so we can either choose to isolate mass 1. Okay, so we can isolate mass 1. And if I kind of quickly draw the forces, 50 newtons and force of your 2 on 1. And I could also isolate mass 2. So here I'll quickly draw it as well. So in this case here, we have the force of 1 on 2 and the force of 3 on 2. Now, the reason why we can actually isolate both, and we can actually find it using both, is because even though, yes, they've asked me for the force of 1 on 2, the force of 2 on 1 is the same magnitude. Yeah. So therefore, we can actually still solve for this and it will still give me the correct answer. Okay. So in this case here, we can see that we have two unknowns in this free body diagram, but we only have one unknown for this one. So therefore, I am going to opt to do free body diagram 1. Okay. So here, we just redraw it quickly. So here we have mass 1, and you have your 50 newtons and the force of 2 on 1. Okay, so if I kind of use my net force equation again, so net force is the sum of forces. So in this case here, it's 50 minus by force 2 on 1, and that equals to MA. Okay, so now I can rearrange to make force 2 on 1 the subject, because that's what I'm trying to find. So force 2 on 1 equals to 50 minus MA. So now we can just sub in our values. So because we are looking at only mass 1, we only include the mass of block 1. Okay, so therefore the mass of 1 is 20 kilograms times by the acceleration of block 1. So we know from above the acceleration of the whole system is the acceleration of each block. So therefore that is 1.1. Okay, so as a result, we get a force of 27.8 newtons. Okay, so that's part B done. So let's have a look at the next one. So now they're asking me for what is the force exerted by mass 3 on mass 2. So in this case here, they're asking me to find this one here. Okay, so if we have a look at this, now we kind of have two options again. Okay, so we can either, so I'll quickly draw it here, we can either isolate M3 or we can isolate M2. Okay, so if I kind of quickly draw the forces, so on your block 3 is force 2 on 3. On block 2, there's going to be two forces. So force 3 on 2 and force 1 on 2. Now, in this case here, can you see how your free body diagram for block 3 only deals with one force? So it's going to be a lot easier compared to this one here. Okay, so therefore, I'm going to choose to isolate block 3. So in this case here, I rewrite it again. So force of 2 on 3, and that's pretty much it. So in this case here, net force is equal to the force of 2 on 3, and that equals to MA. And now I can just plug in my values. So I know that the mass of block 3 was 10 kilograms, and the acceleration of block 3 is the same as the acceleration of the whole system. So therefore, that is still going to be 1.1. Okay, so therefore it's 10 times 1.1, and that gives you 11.1 newtons. Okay, so this is it. This is the question done. Okay, so hopefully that makes sense, and let me know if there are any questions.